the time response of a standard second order system to a step input is 1 minus k e power minus 2t sine of 2 pi t plus phi. What is the number of oscillations, assuming 2% tolerance, before the response settles? The response settles at the settling time. Okay, and then the number of oscillations is given by one oscillation is completed in twice the peak time. The number of oscillations is given by the total time to settle divided by 2 TP, because for an underdamped waveform, yes, 1 minus e power minus alpha t sine omega dt plus phi, representing that it is some underdamped response. And for an underdamped waveform, dear, okay, this is known as the peak time. Okay, and the time for the first undershoot, this is the first overshoot, the time for the first undershoot, that is 2 TP. So this is known as one cycle. This is what is known as total one cycle. So up to the settling time, let's say this is the settling time. How many cycles are there? It is given by the 2s divided by 2 TP. But eventually, what is TS and what is TP? For that, we need some parameters. So step response is given to you. Okay, we can just capitalize on that. What is given to me? Step response has been given to me, and the step response is given to you as 1 minus k e raised to the power minus 2t sine of 2 pi t plus phi, So look simple only, guys. Look simple, because this has to be alpha 1 minus e power minus alpha t upon under root 1 minus zeta square. So we don't need the value of k here. Alpha will be sufficient, into sine of omega dt plus phi. So omega t seems to be 2 pi. So now what is the settling time and what is the peak time? Sir, the formula for settling time for the 2% tolerance, that is 98, output should settle to 98% of the desired value. For underdamped, it is given by 4 by zeta omega n. The settling time for underdamped, it is given by 4 by zeta omega n, and which is alpha. Zeta omega n is alpha. Okay, so 4 divided by 2. So the settling time is 2 seconds. And if I want to discuss the peak time, so sir, peak time is given by the formula pi by omega d. Okay, so that is pi divided by 2 pi. So that is 1 by 2 second. And dear, in this last moment, gate is just 4 days away. I hope that you don't need any derivations or detailed discussions, because what you are also looking for is a quick and a crisp question session. So let's focus on how to solve the question with the required concept and formula. No derivation, no idhar udhar ki baat. Whatever is required at the end time, only that much. So peak time is 1 by 2 seconds. Okay, so now when I want to write down the number of oscillations, so kitna ho gaya ye? Number of oscillations, how much this turns up? Okay, sir. So I've got my settling time as 2 and I've got my peak time is equal to half. Settling time was 2, na? Correct. And peak time is equal to half. So this, I think, turns out to be only 2 cycles. Okay. This only turns out to be 2 cycles. Yes. So it will only have 2 cycles till the settling time, as per the given data. Clear, eh? All right. Done. Badhiya. Chalo. Option B. Yes. Let's go to the next question then on the screen. It is desired to locate the poles. Of the transfer function at -4 and -1 plus minus j2 by using suitable PID controller with the suitable gains Ki. This is not K1, it should be Ki, right? Ki, Kd, Kp for the system given below. What should be the value of Ki plus Kd plus Kp? Ki plus Kd plus Kp. What should be the value of this? Okay. What should be the value of this? Kp plus Ki by S plus Kds. Clear? Right. So it's not a very elaborate or a difficult question on PID controller. It is just a very fundamental question where you have to use this PID controller, and finally the poles of the system should be located here. So first of all, what is the characteristic equation as per the system? Okay, what should be the characteristic equation? Okay, 1 plus GSHS, HS 1 hai. So 1 plus Kp plus Ki by S plus SKD multiplied by, these two are cascaded, so multiplied by 10 upon S plus 4 should be equal to 0. So I should be getting S. So that will become S square into S cube, then S square into 4S square plus, okay, plus ये हो जाएगा SKP into 10, तो 10 SKP plus 10 KI plus S square KD into 10, तो 10 KD S square equal to the 0. Or let me rearrange. So what is the final characteristic equation is S cube plus 4 S cube plus S square को combine करेंगे तो 4 plus 10 KD, 4 plus 10 KD multiplied by the S square, okay, plus S, so 10 KPS, 10 KPS, that's it, only one term of S, plus 10 KI, plus the 10 KI equal to 0. This is what is the characteristic equation, okay, okay, ठीक है, चलो, which mock test? Electrical control system has good weightage for electrical. Now what are the required poles? S is equal to -4 and minus of 1 plus minus, minus of 1 plus minus J2, minus of 1 plus and minus J2. Okay, now by the given poles you can form a characteristic equation. Okay, by the given pole you can form a characteristic equation, or you can use the quadratic equation fundamentals, cubic equation fundamentals. That is, if I want to talk about the sum of poles, -4, okay, -1 plus J2, -1 minus J2, the sum of the roots should be given by minus of 4 plus 10 KD divided by 1. Okay, simple. So from here, 4 plus 10 KD is equal to J2 cancelled is equal to -6, minus cancel कर दिया यहाँ पे, that is equal to 6. So from here the value of KD should be 2 divided by 10, 0.2, number 1. Okay, then let's go to the last coefficient that always represents the product of the roots. Okay, ठीक है, ठीक है, नहीं indirectly there Madhu, indirectly होता है. So look into this. The last is the product. So -4, -1 plus J2, -1 minus J2, and that is equal to the term minus 10 Ki. That is equal to the term minus 10 Ki. Clear? So अब इसको अगर हम open करेंगे, so this is minus first cancel करें, and 4, this is 1 square plus 2 square. So that will become 1 square plus 2 square, and this part will be 10 Ki. So sir, what is the value of Ki from here? Obtain the value of Ki. 4 into 5, 20, 20 by 10, 2. So Ki should be 2. Okay. Now the central term 10 Kp is the product, pairwise product term. Okay. So once it is -4, -1 plus J2, then it is -4, -1 minus J2, and then plus it is the product of -1 plus J2, -1 minus J2. Okay, this is the result. Okay, so अगर हम open करेंगे -4 into -1, 4, then minus J8, a conjugate part will get cancelled. Okay, so let me write down the direct result only. This is 4, 4 plus 4, 8, and this is again equal to 5, 8 plus 5, 13. This is total equal to 13. So the value of Kp is 1.3. Okay, just tally the calculations once. Hai na? Just tally out the calculations once. Okay, so now what is the question? Ki plus Kd plus Kp. Let us come and write down the final answer then. Right. Kp, Kd, Ki. Whatever sequence you add doesn't matter. So 1.3. Sir, what was the Kd? Kd is 0.2 and Ki is 2. So 1.5 plus 2, 3.5. Can you just check your answers? Can you just check your answers? 3.5 total. 3.5 total is the answer. Just check the calculation part once, है ना? एक बार calculation part को देख लेना. So total answer is known as the 3.5. Done, sir? Yes, Ashok Raghu, clear. 3.5. That is the correct answer. That is known as 3.5. Chalo, done hai. Let's move ahead to the next. Characteristic equation of a system. characteristic equation of a system, MSQ question, is given to you. S power 6 plus S power 5 plus S power 4 plus 4S square plus 4S plus 4 equal to 0. Okay, and we have to select the correct options. One or more than one options can be correct. It is a MSQ, multiple select question. Multiple select question. So first of all, number of poles, LHP, RHP, imaginary axis, we have to go about the RH criteria. So let us start building the RH. The first row is S power 6 and the second is S power 5. S power 6, 1, 1, and then S square. Look into the even coefficients only. 1 and 1 and 4 and 4. 1 and 1 and the 4 and the 4. And S power 5, 1 and then 0. Beech mein 0 hoga. 0 into S cube. All odd coefficients you have to take. Then 4. So 1 and 0 and 4. 1, 0, 4, 0. Okay. S raised to the power 4. Dash minus that. This is 1 minus 0. 1. Okay. 4 minus 4. 0. 4 divided by 1. 4. 0. Next. S cube. Okay. 0. 4 minus 4, 0. This element will be 0 because the top two elements are 0 there. Top column. Last element is always 0. Okay. So dear, what is that you are getting here? What is that you are getting here? What is that you are getting here? You are clearly getting a row of zeros, right? So this is taking you towards the row of 0, and whenever there is the row of 0, we solve for auxiliary equation. Correct? Whenever there is the row of 0, we will take the auxiliary equation. We will take what? Auxiliary equation. We will take the auxiliary equation. Okay. So what is the auxiliary equation? यहीं पे लिख देते हैं, very simple. S raised to the power 4, 0 into S square, this will be 0, so directly 4 into S की power 0, so S की power 4 plus 4 equal to the 0. And then when you differentiate this, next step is differentiate the auxiliary equation, so you get 4S cube equal to 0. So now I will have the modified, dear, I will have the modified S power 3 row. And what is the modified S power 3 row? Okay, the S power 3 coefficient is 4, rest all are 0. So 0, 0, 0. 0, 0, 0. Rest all are just 0, 0 and 0. Clear? Hai? Rest all is just 0 and 0 and 0. That's it. This is the S cube term. Okay. This is the S cube term. Now, let's continue the Routh-Hurwitz in the regular manner. Let's keep going. So now I have S square. Okay, 0 and 0. Correct? Eh? This was 0, 0. Then 4 into 4 divided by 4 is a 4. First element 0. So multiple cases coming up here. Right? This is 0 because it was 0 hai. Last element always 0. So now this is corresponding to the case, dear. This is corresponding to the case where first element of the row is 0, and whenever the first element of the row is 0, you replace that first element by a small variable epsilon, which may be positive or negative, your call. Let's call it as positive small variable, okay, tending to 0, and solve the Routh-Hurwitz in terms of epsilon. So S power 1, 0 minus 16 divide by epsilon. This is 0, ये 0 है, ये 0 है. So next element 0, last element always 0. So last row S power 0, x बोल देते इसको, x into 4 by x, 4 triple 0. Correct है? 4 triple 0. Done है. So this is what I have obtained. This is what I have obtained. Now, even though epsilon tending to 0, pay attention. This is epsilon tending to 0. So this term will be tending to minus 16 by 0. We wanted the sign actually, and sign we have got minus infinity. We know it will be undefined, but what undefined? Minus infinity. Minus infinity. ठीक है, done. चलो ये हो गया. Now, whenever there is the auxiliary equation, case, I'll write down the answer using two columns. Number 1, what is the order of auxiliary equation? What is the order of characteristic equation? So what is the order of auxiliary equation? S power 4 mein hai, and total characteristic equation is S power 6. That is the 6th order. Now, for any auxiliary equation, because of symmetry, the number of LHP roots and number of RHP roots are always same. Dear, for any auxiliary equation roots, because of the symmetry, number of LHP and RHP roots are always same. Then what is the number of RHP roots? Very detailed, I have explained these sessions earlier in the theory classes. Abhi keval apply karna hai. What is the number of RHP root? Number of sign changes from the auxiliary equation part. So where is the auxiliary equation here? In this part, how many sign changes are seen? In this much of the part, how many sign changes are seen? In this much of the part, oh, dekho, 1 plus plus, epsilon is plus, then I get minus, and then I get plus. Minus plus. Clear? 2 sign changes. How many sign changes? Plus to minus, minus again back to plus. These are 2 sign changes. And because there are 2 sign changes, there will be 2 in RHP. 2 roots of auxiliary equation in RHP. But because of symmetry, 2 in the LHP also. So now dear, tell me, if there are j omega roots, that is only in the auxiliary equation case, but how many in the j omega right now? Sir, there are total 4 roots. 4th order equation hai. There are total 4 roots. Okay, out of which 2 is in LHP, 2 is in RHP. So how many is left for j omega? How many is left for the j omega? Actually, nothing is on the j omega this time. There is no j omega roots. There is no j omega roots. Now come to the characteristic equation. Characteristic equation mein how many to the RHP? Characteristic equations are how many to the RHP? How many to the RHP? Total number of sign changes from top to bottom, and total also is 2 sign changes. Total also 2, right? How many on j omega axis? That is 0. That is always obtained. That is always obtained from the auxiliary equation data. And the remaining then is in the LHP. Okay, so total order is 6. 2 is in RHP. None is in j omega. So 4 LHP roots for the characteristic equation. 4 LHP roots for the characteristic equation. No, nothing on the imaginary axis, Surajit. Nothing on the imaginary axis here. Clear hai? So that means the number of poles in the LHP are 4. Looks good for me. LHP mein 4 nikala na? Okay, the number of poles in the LHP 3, no. The number of poles in RHP is 2. Number of poles on imaginary axis are 0. Correct. It is ACD. It is the ACD. A, C and D also. D also. Number of poles on imaginary axis nil. ACD. And because there are 2 RHP roots, if they wanted to talk about stability of the system, so the system is unstable. Suppose if they wanted to talk about stability, system is unstable. Okay, the correct answer is ACD. Yeah, definitely it has to be 2 marks. It has to be 2 marks. Chalo, main mention kar deta hu na. I'll keep writing. This one can be expected for 2 marks, right? MSQ question. Previous one is also a decent question, right? It's although NAT. I'll keep writing. Expect for 2 marks. Expect for 2 marks. The previous one also. Usse previous chale jaye, so this one is simple. This one is MCQ, but very simple. This can be expected for 1. Very basic calculation. Okay. Chalo. Let's go to the next. Okay. So I'm just giving the expected marks also. Next, number 4. The forward path transfer function of a unity feedback system is given to you. Okay, k s plus 2 upon s plus 3 s square plus 2s plus 2. The angle of departure from the complex poles. NAT question hai. Angle of departure तो 100% 2 marks category में जाता है. मतलब if IIT makes it really lengthy, otherwise little less chances for BDR. ठीक है. चलो. So what is the angle of departure case? What is the angle of departure case? So first of all, let me write down the calculations. What are the open loop zeros here? There is the open loop 0 at -2. Then what are the open loop poles here? So poles is -3 and then -2 plus minus root over b square. That is 2 square 4 minus 2 AC minus b plus ठीक है, divided by 2a. So the poles are -3 -1 plus minus j2 ka 2 j2 by 2. So that is j -1 plus minus j. Perfect. That is what are the poles. Okay, that is what are the poles. Now a small geometry. Okay, and we solve the question. What are the poles? -1 plus minus j, -3 and -2. -2 तो 0 है. poles -3 and -1 plus -j. पहले इसको देख लेते हैं. This is one of your conjugate pole. Okay, -1 plus j. So this is -1 minus j, and then you have the pole at -3 and a 0 at -2. Okay. First of all, guys, let us say I am calculating. Let us just say that I am calculating the angle of departure for the pole -1 plus j. Okay, what I will do is join this pole. You can go by the formula also, angle GSHS equal to 180 degree or -180 degree, but this is very simple actually if you do it by geometry. Join this pole with respect to all other poles. Join this with respect to all other poles actually. First, calculate the angle that it subtends with respect to the poles. Okay, so let's say this is the pole P1. So let's say this angle is phi P1. Let's say this angle is known as phi P1, and this angle with the other pole, because it is conjugate, it is making a vertical line. So phi P2 to 90 degree because it's a perpendicular line, vertical line. Okay, so only thing is, what is the value of phi P1? Phi P1, internal angle of a triangle, trigonometry से आ जाएगा, tan inverse the height, that is 1, divided by the base, -3 से -1, base is 2, तो tan inverse half. Let it be like this, बाद में solve करते हैं. Okay, now join this with respect to the 0 as well. Join this with respect to 0 as well. Okay, and let's say that this particular angle, this is known as phi Z1. There is only one 0. And what is the value of that phi Z1? That is known as tan inverse height. Height 1 hai. Base -2 से -1. Base is also 1. So tan inverse 1, that is 45 degree. Okay. Now dear, what is the formula for angle of departure? Angle of departure is given by the formula 180 degree. The forward part transfer function of a unity feedback hai. Okay, and gain k nothing mentioned, so k will be positive only by default. So we'll apply the regular formula, root locus 180 degree minus of phi p minus phi z, where phi p is sum of angles subtended by all other poles, that is phi p1 plus phi p2. Phi p1 आया है tan inverse of half, phi p2 is 90. I'll just soon calculate and write down. Phi z is the sum of angles subtended by all the zeros, but there is only one zero whose angle was phi z1, and that was 45 degree. So what is the angle of departure then? 180 degree minus of, chalo, let me calculate this value, dear. Let me calculate what is the value of the phi p. The phi p is 116.56. Okay, so here I get 116.56 degree plus 45 degree, sorry, minus 45 degree. Phi p minus phi z. ठीक है. तो 108 ऑप्शन है, NAT है. So 108.44 degrees. 108.44. Yes, Surajit. Correct answer. 108.44. ठीक है, रघु, just recheck it once. 108.44 angle of departure based question. Plus or minus. Why plus or minus? देखो, why the plus or minus? Because we know that the angle of departure we have calculated right now for -1 plus j pole, and that is 108.44 degree. So dear, what is the angle of departure for its conjugate pole? That will be only changed in sign but same magnitude, तो -108.44. Okay, ठीक है. नहीं, डिग्री में बोला है ना, तो कीप इट इन डिग्री ओनली रवि. यस अशोक, करेक्ट आंसर. ठीक है, तो 108.44 द एंगल ऑफ डिपार्चर्स आर प्लस माइनस 108.44. डन है. दैट इज द एंगल ऑफ डिपार्चर, हेंस कैलकुलेटेड. क्वेश्चन नंबर 5. Question number 5, a fundamental MCQ question. A fundamental MCQ question from the Nyquist plot, but expect for how many marks? चलो इसको भी show कर देते हैं. You can expect this for normally 2 marks. Why? Because I'll tell you. The loop transfer function of a feedback system is given to you, s plus 3 upon s square s minus 3. Take the Nyquist contour in the clockwise direction. So, okay. Then the Nyquist plot of the GSHS encircle. Okay, so now what is the formula? Nyquist plot GSHS encircle minus 1 plus J0. Number of encirclements. Third pole is the pole whose angle of departure we were calculating, na, Sai Charan. With respect to that, there are only 2 remaining poles, na? That you have to see. Okay. Acha ji, theek hai. So what is the Nyquist plot of GSHS encircles minus 1 plus J0? Now, how does it encircle? How many encirclements? Okay, normally, you might be thinking that we need to draw the Nyquist plot. Okay, but we can solve this question without drawing the Nyquist plot. We can solve this question without drawing the Nyquist plot. N is equal to, because clockwise bola hai na, the formula will be P minus Z. Okay, so what is N? N is known as the number of encirclements of minus 1 comma 0, that is minus 1 plus J0. Okay, right, minus 1 comma 0 by the Nyquist plot. I'll show you that we don't need to sketch Nyquist plot to getting this number of encirclement. Number of encirclements of minus 1, 0 by the Nyquist plot in the anti-clockwise sense. If it is clockwise, then I will take the minus, n equal to minus. Okay. Now, what is the P plus? Okay. What is the P plus? Okay. P plus we just used to signify the right hand side for clarity. The P plus is the number of poles of the open loop transfer function, that is GSHS. Number of poles of GSHS in the RHP. What is the Z plus, sir? That is known as the number of zeros of GSHS. No. Zeros of GSHS you can take if you are looking into the encirclement of 0, 0, actual origin. But here we are looking into encirclement of minus 1 comma 0, the number of zeros of 1 plus GSHS. Number of encirclements of 1 plus GSHS, that is the roots of characteristic equation lying in the RHP. Okay. That is what I need. So dear, I am telling you now that for this question, we may not require to draw the Nyquist plot, and we can do this directly if I know P plus and Z plus. Do I know the P plus? Number of poles of GSHN in RHP. Okay, what are the poles? S is equal to 0, 0 and plus 3. So how many poles are in RHP? It is equal to the 1. Sir, how many are the poles are in RHP? That is equal to 1. Clear? That is equal to 1. How many poles in RHP? 1. Done. Okay. That is P plus. Now what is Z plus? Number of poles, number of zeros of 1 plus GSHS. That is roots of characteristic equation. Can I form the characteristic equation? Can I form the characteristic equation? 1 plus GSHS, that is 1 plus S plus 3 upon S square S minus 3 equal to 0. That is going to give you S cube minus 3S square plus S plus 3 equal to 0. Okay. So when I feed this into the Routh array, we can get roots of this in the RHP. RH is there. So 1 minus 3 and plus 3. S ki power 1 minus 3 minus 6 upon minus 3 plus 2. Last में 0, S power 0, 2 into 3 by 2, 3 and 0. How many sign changes you have faced? 1 plus 2 minus and then minus 2 plus. So there are 2 sign changes. Right. So I can say 2 RHP roots. Okay. Right. 2 RHP roots. So roots of 1 plus GSHS, that is known as Z plus. Z plus is equal to 2. So now can I say the value of N? N, as I told you, is P plus minus Z plus. P plus is 1 from the beginning analysis, minus Z plus is 2. So the value of n is -1. Now what is the significance of -1? I told you, right? What is the significance of -1? So n, that is known as 1. My 1 minus means clockwise. Minus means clockwise, right? Okay, it is once clockwise. Yeah, Ashok, health is good. A little tired, you can say. Very much exhausted, but not a big problem. So once in the clockwise direction, it is option number A. It is once in the clockwise direction, that is the option number A. Yes, by default you have to do that, Surajit, correct. Chalo, done. Next, let's move ahead to the next question, the sixth one here. Here it is. The Nyquist plot of two functions G1s and G2s are shown below. Okay, the Nyquist plot for the product of two. Nyquist nahi, actually just call it as the polar plot. It's not the complete Nyquist plot. केवल polar की बात कर रहे हैं यहाँ पे. Polar plots of two functions G1 and G2 are shown below. What is the polar plot for the product of? Okay, what is the polar plot for the product of G1 and G2? Okay, some more variety from the Nyquist plot. ध्यान देना. Some more variety from the Nyquist plot. So let's go ahead and solve this. Let us go ahead and solve this. So first of all, let me highlight this actually. इसको broad कर दूँ so that you have clarity. What exactly is the polar plot given? Okay, this portion, the polar plot. This is the polar plot actually. And here, this is the polar plot actually. Now, there are four options given to you. So let's understand first. Let me again redraw that. This is one, this is the one. And let's draw the direction with respect to omega. In the first one, omega 0 is at origin. So we are going 0 to infinity towards negative real axis. And here, omega equal to 0 is on the extreme. So we are going 0 to infinity. Okay. Now please pay attention. The point to be noticed is, can I guess G1s and G2s? Both the polar plots are purely on the real axis. Okay, are purely on the real axis. There is no imaginary term. Can I say like that? There is no imaginary term actually. Okay. So both polar plots, the point to be noted, are on real axis. Okay. So if I want to talk about the Gj omega, okay, it should not have any imaginary part. Gj omega should be purely real. Okay. Should be purely real. Okay, that means when I want to take the GS, it should be in the form of ks square or k by s square, because when you put s equal to j omega, it cannot be ks. If you take ks, it becomes kj omega. If it is s square, j omega square and j square is -1, that is real. So that will be eliminated. ठीक है. अब आप देखोगे here, the value at origin is origin. The value at 0 is 0. So for the first one, I can take G1s is equal to ks square. Okay, because it satisfies the origin. And here the value at origin is infinity. So for here, let's take k by s square. Okay, k by s square. Yeah, value at the origin is infinity. The 1 upon infinity will be 0. So first one will be k by s square. Next, it's not necessary same k. So k1 or k2 लिख लेते हैं. k1 s square and k2 s square. So how to get the k1, k2? For that, some intermediate point is given to you. That at omega equal to 4, ये properly आपको show कर देता हूँ. At omega equal to 4, okay. At omega equal to 4, what is given? Mod of G1 j omega should be 2. The magnitude, distance from origin is the magnitude, that should be 2. Okay, so रख लेते हैं इसको k1 into J4 whole square, iska modulus, this will be equal to 2, right? So J4 minus 16, so 2 by 16. What is the value of K1? It is 2 by 16 or 1 by 8. Ye ho gaya one of the case. Then here, at omega equal to 4, the magnitude is 3. Here at the omega equal to 4, the mod of G2 J omega should be 3. That is modulus of kitna? K2 by S square, that is J4 whole square should be equal to 3. So what is the value of K2 coming up here? 4 square, 16 into 3, 48. So what is the product of them now? Very simple now. Okay, solution looks simple, but understanding, manipulating the question requires your basic understanding about the plots, nothing much. So G1S into G2S. What is the G1S? Right, K1 का value 1 by 8 था, तो 1 by 8 S square multiplied by what is the G2S? G2S is K2 by S square, तो 48 divide by S square, तो S square got cancelled, 48 by S equal to 6. So please pay attention. Okay, what is G1 J omega, G2 J omega? Okay, that is 6, or that is 6 plus J0. This is also purely real. But the point is, since it is purely real, it is not a, see, it is purely real, okay, but it is not a function of omega. It's a fixed point. Okay. It's just a point. 6 plus J0 is like the point 6 comma 0. Okay, it's the point 6 comma 0, and that is why the correct answer is gonna be option number B. Correct answer for this question is the option number B. Okay, some different variety from the Nyquist plot. It is the option number B. Clear hai? Any doubt, keep asking me, or else I'm proceeding to the next question. A Bode plot, simple one. Bode plot से एक fundamental question है. The magnitude frequency response of a control system is as shown in the figure. What is the value of omega 1, omega 2 and m in dB? What is the value of omega 1, omega 2 and the magnitude in dB? And the magnitude in dB are respectively how much? Are respectively how much? Omega 1, omega 2 and magnitude in dB. Tell me. The omega 1, the omega 2. Okay, so let's start calculating this. Fundamental hai exam. Okay, it's a fundamental. So let us analyze this. Initial slope is 0. Okay, n equal to 0, and initial magnitude is given by the formula 20 log k. Magnitude is 20 log k, right? It is 20 log k. तो यहाँ से k आ जाएगा, but I need first of all omega 1, omega 2 and the magnitude m. So let us focus only on the omega 1. K की need है नहीं इस question में, ठीक है? So when I look into this slope, this is 20 decibel per decade. Okay, the point to be noticed here, my lord. देखो इसको कैसे simplify करें? 20 decibel per decade slope is also equal to, okay, it will be a point on the real axis, na? Why on the non-real axis? What is that you're looking actually, Surajit? Okay, so 20, it is also known as 6 decibel per octave. 20 dB per decade slope is also equal to 6 dB per octave. So now why I'm choosing 6 dB per octave? Because I immediately noticed, ध्यान ये देना, I immediately noticed that the change in the magnitude 20 say 26 is 6. And the change is 6 decibel for 1 octave. That means, dear, that means this should be 1 octave. Clear? So omega 1 aa gaya. Octave is what? Octave is what? Octave is a factor of 2. Octave is a factor of 2. So it is 10 times 10 into 2, that is equal to 20. So sir, omega 1 is 20. Okay. Now, the slope of the next line is minus 20 decibel per decade, which can again be written as minus 6 decibel per octave. Clear? This can be written as minus 6 decibel per octave. Okay. अब देखो, here if I come 26 to 20, इसको दो part में split करते हैं. First, let us talk about this portion, this point. Okay. So let's say this is some omega. So the magnitude becomes 26 to 20. So drop by 6, okay, reduce by minus 6. Reduce of -6 is possible for 1 octave of the frequency. So that is why again, dear, this portion should be 1 octave. This portion should be 1 octave. So what is the omega? Okay, 1 octave matlab twice of the previous omega, that is omega 1, twice of 20. So this part is 40. Now have a look into this. This is 20 to 0. 20 to 0 matlab reduced by 20. So the magnitude change -20. Now -20 should change. -20 should change for 1 decade. So sir, how much should be this one? Right, this one. This should be 1 decade actually. Right, 1 decade matlab omega 2. Decade is a factor of 10. Decade is a factor of 10. So what should be the omega 2? Omega 2 should be the 10 times the previous omega. That is 10 times the 40, and omega 2 400 aa gaya. Can we match anything from here? So omega 1 is 40 and omega 2 is 400. Sorry, omega 1 was 20. 20 and 400. Okay, 20 and 400, but still magnitude is not matched. We have to calculate this magnitude. Okay, so is magnitude pe bhi aa jate hain ab, and let us have a look into this particular line for this magnitude. Let us have a look into this line. इसको separate करते हैं. Right, this is the line where the magnitude is 0 dB and the final magnitude is m. That is what I am looking for. The frequency, this is the omega 2, which is 400. I'm sorry, there is a typo error. If this is 400, ye 1000 here. Okay, please make a correction. This is 1000 actually. This is not 100. This is 1000. Clear? Ye 1000 hai. Okay, so here the omega, the slope of the line is same, -20 decibel per decade. Iska slope hai -20 dB per decade. Here the magnitude is m. Here the omega is 1000 and here the omega is omega 2 जो कि आया 400. ठीक है, these are the points known to me. These are the points known to me. तो यूज कर लेते हैं ना. देखो, slope equal to -20. That is given by y2 minus y1. y2 minus y1, m minus 0 divided by x2 minus x1. In a Bode plot, x-axis always represents log omega axis. So log of 1000 minus log of 400. Never write down omega 2 minus omega 1. It is log omega 2 minus log omega 1. यहां से सॉल्व कर लीजिए. Magnitude is -20. This is log of 1000 by 400, log of 2.5 actually. So -20 log of 2.5. आंसर लिख लेते हैं 7.95 or approximately 8. Approximately 8, -8 decibel. So the correct answer is D in that case. Okay, it is D, -8. Please check out. Please check out. Yes, Jagdish and Ravi Shankar, please check out. Raghu, correct. It is going to be D, -8. C nahi, D. It is -8. Check out calculations 1. Okay. Done. Done. Okay. Chalo. So let's move ahead to the next question. Number 8. The following frequency response, again in a tabular form the data is given. The frequency response test data were obtained for the forward path elements of a unity feedback control system. What is the type of the system? Because question is on type, that is why they have clearly mentioned unity feedback. Type is the number of poles of GS at origin when it is connected in unity feedback configuration. Okay. Right. So the only thing that you can use here is, can I get the information about the initial slope if I plot this data into the Bode plot? If I plot this frequency data on Bode plot, okay, what is the initial slope? Okay. If I plot this on the Bode plot, what's going to be my initial slope? So initial slope, let's have a look into the change in the magnitudes initially. Okay, 28 minus 24. 28 minus 34 divided by log, again I am telling you, log of 0.2 minus 0.1. That is log 2. Okay, so that becomes how much? Minus of 6 divided by log 2, and you calculate, you will get this as minus 20 decibel per decade. The initial slope is minus 20 decibel per decade, whereas the initial slope should be represented as minus 20 n decibel per decade, right? So comparing both minus 20n and minus 20, if I compare both, the value of n will be equal to 1. Clear? The value of n is equal to 1. Okay, the type of the system is 1. The type of the system is 1. The type of the system is equal to the 1. Clear? This is fundamental question, but you have to just connect this to the Bode plot. That is the only input you have to provide from your side. Suppose this data was plotted on Bode plot. For the initial set of frequency, what would be the slope exhibited? What would be the slope exhibited? That can decide the type of the system. This was how much? 8th. Moving ahead to the 9th question. If the compensated system shown in the figure has a phase margin of 60 degree, okay, at the crossover frequency of 1 radian per second, then find a value of the gain k. Find a value of the gain k. So first of all, let me take the open loop transfer function here. Let me take the open loop transfer function, and that should become multiplying both k plus 0.366s into 1 upon s plus 1. So directly let's write divide by s plus 1. So dear, what is the gj omega hj omega? Let's convert it into the frequency domain. Gj omega hj omega, right? K plus 0.366 j omega is divided by j omega 1 plus j omega. So what is the magnitude and what is the phase expression? Magnitude mod gj omega hj omega. Magnitude ka expression will be the root over of k square plus 0.366 ka square divided by omega again under root of 1 plus 1 square plus omega square. Okay, what is the angle expression? Angle gj omega hj omega, suppose that is the phi, and that will be given by numerator tan inverse y by x करेंगे तो 0.366 omega divide by the k, denominator के लिए subtract j omega pure imaginary term तो 90 degree, again subtract for denominator tan inverse omega y1, that is tan inverse omega. Now what is the important thing here? They have first given phase margin and crossover frequency both. Okay, so you are given phase margin of 60 degree, correct, and the phase margin is calculated at the gain crossover frequency. Okay, so at 1 radian per second, the phase margin is the 60 degree. At 1 radian per second, the phase margin is known as the 60 degree. Okay, acha, whereas what is the phase margin formula? The phase margin is given by 180 degree plus angle gj omega g hj omega g. ये 60 रख दिया. So what is the angle gj omega g? hj omega g will be 60 minus 180. That is minus 120 degree, right? Now we know that omega g 1 hai. So calculate the angle, take the angle expression from the previous slide. कितना आ गया ये? Tan inverse of 0.366 into omega की जगह 1 divide by k minus 90 minus tan inverse omega is the 1 here, is minus 120 degree, sir. Okay, is minus 120 degree. So tan inverse 1 is 45. So you are only left with tan inverse 0.366 upon k should be equal to 90 plus 45, 135. 135 minus 120, 15 degree. Okay, so 0.366 upon k will be the tangent tan of 15 degree, right? From here, I will write down directly the value of k. 1.36. The value of k 1.36. 1.36, correct? Okay, 1.36. 1.36. Done? 1.36. NAT type question. No, not NAT, it's an MCQ question. Here it is. Option number C. Okay, so this is MCQ, but face margin decent question can be expected for 2 marks. But simple decent question. Okay. No, Ravi. Chalte, next question ki taraf. This is number 9. This is the number 9. Let's go ahead to the next question, number 10 of the Super 11. Consider the system described by the state equation given below. X dot is AX plus BU, Y equal to CX. Okay. If UT is the unit step input, determine the output of the system. Now, let us quickly recall that using the state model, I need to determine the output YT and the output Y. Y is equal to C into X. Okay, C into X. Okay, how to obtain the X? Y is Cx, that is mentioned. How to obtain the X? Okay, xt, that is the state vector, is first obtained in the 0 input condition and then obtained in the 0 state condition. It is obtained in 2 forms. Xt, which is known as the state vector. Let's find the ZIR as well as the ZSR both. ZIR as well as the ZSR both. Okay. Chalo. No, not required. Even if you calculate transfer function, even if you calculate transfer function, you can calculate the output when the system has 0 state, because transfer function is only will only enable to solve the problem of 0 initial condition. But here the initial condition is non-zero. That is why transfer function se question pura solve nahi hoga. You have to take state space approach only. Okay, you have to take the state space approach. Now, before I do anything, ZIR, ZSR, I have to calculate the state transition matrix. That is going to be required in both. So multiple formulas will be revised in this question. Let us calculate the state transition matrix. Okay, which we normally call it as phi t, which is known as e raised to the power at, and this is calculated as inverse Laplace of si minus a whole inverse. The inverse Laplace of the si minus a whole inverse. Okay, so now what is the A matrix? 0, 1, minus 1, minus 2. A matrix is given to you. 0, 1, minus 1, minus 2. 0, 1, minus 1, minus 2. Now I want the Si minus A. So S into 0 minus 0. Si, S0, 0, S. That is S into I. Minus the given matrix. So what is the Si minus A? That is S, 0 minus 1. 0 minus minus plus 1 and S minus minus 2, S plus 2. That is the Si minus A. Okay. Now, what is the Si minus A whole inverse, sir? Step by step. Si minus A whole inverse. We actually call it as capital phi S function. In Greek, capital phi. Greek mein waise there is no caps or small, but let me call it as capital phi S. Si minus A whole inverse. Then we will take the inverse Laplace to get the time domain function phi t. Okay, so that is Si minus A whole inverse, and inverse of any matrix is adjoint upon determinant. So adjoint Si minus A upon determinant Si minus A. 2 cross 2 ka adjoint is very simple. Exchange the diagonal elements. Exchange the diagonal elements and change the sign of the remaining elements. Minus 1 or 1 ka sign change kar dena hai. ठीक है. Divided by the determinant. तो determinant कितना होता है? S plus 2 minus minus will become plus 1. Okay, S plus 2 plus 1. That is the Si minus A whole inverse. Okay, that is the Si minus A whole inverse. Right. So let me rewrite this term once again. Phi of S can be written as S plus 2 1 minus 1 S whole divided by the S square plus the 2S plus the 1. S square plus 2S plus 1. Perfect. Eh? Okay, so if we want, we can divide this inside. Okay, S square plus, ये कितना हुआ? S square plus 2S plus 1, and that is nothing but S plus 1 का whole square. Am I correct? That is the S plus 1 का whole square. चलो यहाँ पे थोड़ा बहुत पार्शियल फ्रैक्शन में मेहनत करना पड़ेगा. आई थिंक द डेटा इज परफेक्ट. देन इट्स लिटिल बिट कैलकुलेटिव हेयर. लिटिल बिट कैलकुलेटिव है. S plus 2 because that is coming to be S plus 1 का whole square. ठीक है, there isn't any option. Okay, that is little bit calculative. Okay, so we can't do much about that. चलो तो let me write down this now. Okay, so what is that? I have S plus 2 upon S plus 1 का whole square into 1 upon S plus 1 का whole square minus 1 upon S plus 1 का whole square and S upon S plus 1 का whole square. अच्छा, वैसे देखा जाए ना, if I solve it in the time domain, if I solve it completely in Laplace domain, तो maybe calculations are reduced. चलो, anyways question is not asking you state transition matrix ना, forget. चलो नहीं निकालेंगे तो क्या होगा? One more approach I have. Try करते हैं उसको. So first of all, now I will give you the formula for zero input response state vector solution. Okay, so x zirt, which is actually given by phi t into x0 into the initial state vector. ठीक है, तो अगर लाप्लास में सॉल्व कर लें x zirs, okay, that will be phi s into x0 and phi s is already calculated multiplied by x0. x0 तो constant है. Phi of s multiplied by the initial state which is given to be 0 1. So now you will feel that some of the calculations can become simple. How? Multiply करके देख लो. फर्स्ट रो फर्स्ट कॉलम, तो 0 इंटू समथिंग इंटू 0 वैनिश. केवल सेकेंड टर्म लेना है यहां से 1 अपॉन s प्लस 1 का होल स्क्वायर. सो आई विल गेट 1 अपॉन s प्लस 1 का होल स्क्वायर. सेकेंड रो पे आ जाएंगे तो इंटू 0 एंड सेकेंड इंटू 1, तो s अपॉन s प्लस 1 का होल स्क्वायर. दिस इज व्हाट आई एम गेटिंग. क्लियर? दिस इज व्हाट आई एम गेटिंग. एटलीस्ट थोड़ा सिंपल तो हो गया. Right? So what is the x zirs? What is the x zirs? Okay, और simple करते हैं. Forget. I will not take the inverse Laplace here also. Forget. Why I will not take? Have a look into this equation. What is the output equation? 1 1 xt. Okay. Have a look into this. 1 1 xt. 1 1 into xt. That is x1 x2. Clear? So what is the output? x1 plus x2. Please pay attention. What is the output? x1 plus x2. So please pay attention, dear. What is the output yt? In the time domain, it is x1t plus x2t. So applying the linearity property in the s domain also, it is x1s plus x2s. It is your smartness how you can simplify the calculation. Now I have both the state vector in the s domain. When I add them, 1 upon the s plus 1 ka square plus s upon the s plus 1 ka square. Okay, so this is 1 plus s. One of the term is cancelled. Add होने के बाद 1 upon s plus 1. भाई साहब, now it's simple. Okay, now it is the simple. So dear, what is the y zirt? This is the zero input response only. Inverse Laplace of 1 upon s plus 1. 1 upon s plus 1 e power minus t. E power minus t. Finish. Okay, e power minus t या e power minus t ut. Done है. So you have to be a little smart in the calculation. Otherwise, this question can go lengthy for you. Next is ZSR. Let us next talk about the ZSR part. Okay. So x ZSRT. The formula to be revised is now first x ZSRT, then the output. What is the x ZSRT? Dear, this is given by the formula phi s into b into us, and then you take the inverse Laplace of this. This is the actual formula. So let's take it in the Laplace domain only, first of all. So what is x ZSRS? That is phi of s multiplied by b multiplied by u of s. Sir, what is the u of s? U of s is the Laplace transform of the input, where input is given to be unit step. ध्यान देना. Input is given to be the unit step. Okay. What is the b? What is the b? b is 1 minus 1. Okay. So इसको 1 minus 1 से multiply करना पड़ेगा. Okay, maybe little bit calculation, no problem. S plus 2 upon S plus 1 square. S plus 2 upon S plus 1 square. 1 upon S plus 1 square. Minus 1 upon S plus 1 square. Last में S upon S plus 1 square. multiplied by b, which is 1 minus 1, multiplied by Laplace transform of the input, which is 1 by s. ठीक है जी. Now here just multiply. So again, first row, first column, s plus 2, denominator तो common है, s plus 2 minus 1, that is again s plus 1. That is again, look into this, that is what is coming, s plus 2 minus 1 upon s plus 1 का square, and denominator minus 1 minus s, minus 1 minus s upon s plus 1 का whole square, and this is whole multiplied by the 1 by s. So actually what it is going to come, let me take up an extra slide here. So what is that going to come up? X ZSRS, that is turning up to be s plus 1 and s plus 1 एक बार cancel होगा तो 1 upon s plus 1, and here also minus you take common, so minus 1 upon s plus 1 whole multiplied by 1 by s. Okay, so now this is multiplied by 1 by s, so 1 upon s s plus 1 minus 1 upon s s plus 1. Now you may again think, let us now take the inverse Laplace transform. Not required. Why not required? Because try to recall what is the output, that is the x1s plus the x2s. x1s plus the x2s, both are just opposite in sign, so y1s, ys is equal to 0. So what is the yt? Which yt? YZSRT. So YZSRT is turning out to be 0. YZSRT is turning out to be 0. Done? Eh? Okay, so what is the total yt now? The total yt is known as the YZIRT, 0 input response plus 0 state response. 0 input response was e power minus t ut, 0 state response is nil, so e power minus t ut. E power minus t ut should be the answer. E power minus t ut, that is the option number D, sir. Option number D. Clear? Good question. Little calculation laga because both are included. See, sometimes both can be included, but this is little rare. Just for practice, I added both in this question. But yeah, sometimes it may be. There have been 1 or 2 questions in GATE where both were included, ZIR, ZSR, and they were also little time taking. No option. But many a times, at least you can get the question either ZIR or ZSR. Very important area, hai na? Either ZIR or ZSR. Yeah. Not every time, Ravi. Okay, thank you, Dreamer. Yes, state space analysis, I have maybe an old video last year I took, but that was complete, a summary of state space analysis taken, and I think it can help you solve every variety of the question. Okay. Yeah, that is what. ये लिखा है ना यहाँ पे सुराजीत. Because the matrix C is 1, 1, na? That is why. What is the output? x1 plus x2 in time domain, so it is also x1 plus x2 in the s domain also. ठीक है सुराजीत? So because of this equation, y equal to cx. Done है. Super 11, 11th question of control system. The system described by the state equation. Y equal to. Now guys, what is the type of the matrix you have to identify? This question is solved just like that. Okay. Now to help you learn those concepts, I'll just share you. Okay, so I think I have taken it even long back, and that is in Hindi. I have taken it long back, that is in Hindi, but still if you want to, okay. Still if you want to go through it, if you want, much expertise with the state space analysis, it's a complete 3 hour, more than 3 hour video. only on the state space analysis, taken long back, but that is in the Hindi. That is in the Hindi. Okay. I think English में नहीं लिया है YouTube पे क्या? I will take then. मतलब अब तो नहीं, right now GATE is coming up, but for future GATE aspirants I can plan to take. Yes, I think it's only Hindi one which I have taken. Okay, so if you want, you can go through it one. Chalo. Guys, the PDF of this session also, this session will be shared in Telegram. Okay, and the link of Telegram is also shared. And the password भी बता देते हैं आपको. So let's keep it as a simple password. That is state. State of the state space analysis. State of the state space analysis. That is the state of the state space analysis. Okay, the password is going to be state for this PDF. I'll share you the PDF in Telegram tonight. Okay, chalo, done it. So let's move ahead. So what is this type? 010001 minus A0 minus A1 minus A2, and that is actually given. That is actually known as the CCF model. Okay, so now guys, if I start explaining you here now what CCF model is. Okay, yes, Raghu. Then around, another 30 minutes, CCF, OCF, DCF, JCF, this you must know. That is why I have shared you that video. And CCF model का मतलब ही होता है that it is always controllable. Just to test your basic stuff. Acha, I haven't written something with the question, and that this question is MSQ in nature. This question is MSQ, expectation of 1 mark. Expectation of 1 mark. It is always controllable. It is always controllable for any value of the B. So correct answer for the question is ABCD. The correct answer for the question is going to be ABCD. It's controllable if for what matrix B. It is controllable for all these matrices B given to you. All these matrices B given to you. ABCD is the right answer. MSQ question hai ye. But 1 marker. Okay. So you must know this. The CCF model, the observable canonical form, the diagonal canonical form, the Jordan canonical form, right? Okay. Then you must know controllability, observability, what is the Kalman's test, what is the Gilbert's test, all these things. And everything, as far as I remember, everything I have covered in that video. Okay. But guys, again, I'll suggest you. From my side, again, I'll tell you, not necessary to learn anything new now. पढ़ लिया है अभी तक. If you have studied state space, if you just want to watch that video for a quick revision, go for it. Okay, for better concepts and tricks, because there are tricks in that session. If you have not studied state space by chance, then no need. I don't suggest कि last 3-4 days you have to take anything new or any burden. No problem. Leave it. ठीक है. No, Rohit. No partial marking, no negative marking. You will get only if you mark all 4. Even if you mark